Hello, welcome to our next lecture on architectures of machine learning models, architectures of artificial intelligence. And now we are going to talk about the machine learning model lifecycle. When you look at the place of this lecture in our course, this is the first lecture on core processes. And before I start, I would like you to contemplate the running shoes lifecycle. Imagine that you are a producer of shoes like this one, running shoes. That's probably, say, 12th or 13th edition of your shoes. Consider the typical life cycle of such a product development. What happens from the edition number 12 to edition number 13? Why do we decide to create a new version of the shoes? What happens during such a process? How it works? Who is involved in such a process? Let's think about this for a second. Okay, generally it looks like that. You have some requests from the users. Your professional advisors, your consultants, your consumers, all of them tell you, okay, the previous model is good, but, and they have a lot of different ideas for improvement. So those ideas are collected in the needs analysis stage, in this design stage, and your designers create the first proof of concept of the next version. Then you provide this to your users. They get the version number 13, they use it and provide you with some feedback, and your model enters the new improvement stage. Well, obviously very, very simple picture, but still you have the following stages: design, provision, and improvement. In IT world, it may look like that. We have some development stage, next a release stage, and operation stage. Develop, release, operate, compared to design, provide, improve, almost the same ideas. Okay, but obviously it needs to be managed somehow, and many years ago IT managers developed so-called DevOps methodologies, which quite nicely separate the development world from operations world. If you're a developer, you write the code. If you're in operations, you provide the code to the final user and make it running. It's like in a restaurant, yes? A master cook or a cook is in the kitchen, and you have some people who operate in the restaurant, they serve the customers. If you'd like to combine those two roles in a single one, it may generate a lot of problems. So that just simple separation improved the world, and as you can see, it's an instant loop. We have some release, we have some deployment, we have some operation stage. Next, we need to monitor the system. Next, if there is something wrong or there is a new area for improvement, for example, because of the new technologies which came to the market in the meantime, which is very, very hot nowadays, specifically in the area of generative tech, we need to plan for the new release, code it, build it, test it, and release. Yes, so this is DevOps. Okay, why do I tell to you? Machine learning world is quite similar. We also have develop, deploy, monitor. As you can see, the names are a bit different. We develop the model, we deploy the model, and monitor this model in the production. Each stage generates some artifact or signal. Yes, during the development stage, we have a final model. as the outcome. In the deployment stage, this model is provided at an endpoint to the final user as a prediction service. And as I already mentioned, after some time, models may decay, may lose their original value, accuracy, whatever we use for measurement. And we need to have some systems which will identify the situation and generate the retraining trigger for us. Okay, training trigger which will trigger the next stage, which is development stage. Okay, but still, this is the code. So we want to treat it in a DevOps way. Yes, we have some experimentation, development, test area, and we have staging, pre-prod or production area. Okay, experimentation and production environments, methods, sometimes teams. Yes, procedures, different stuff. So this is high-level overview of what's gonna happen in the production with the final model. Stage may be easy or complex. This is easy. Yes, we already saw this example. As you can see, everything is here. We have some data ingestion, we have train test split, we have model training in a single line, we have prediction, we have evaluation, and we save the model. So that's easy. But it may be a bit more complex, and now we are slightly touching a real-life example, which is not that most complex, but let's have a look. We may have raw data coming to us from different systems, yes? And these systems may be, as I already mentioned, external databases, internal databases. External, I mean, for example, external providers like social media providers, which may provide us with data about the behavior of our customers. Or that may be internal databases, data sets in different formats, yes, served to us using different methods. That may be streaming or batch data, yes. This data may have different type. That may be structured data, semi-structured data, or unstructured data. So when you go for the real project, you'll see that this complexity may be very high, and for each of those options we may have different technologies at hand. We need to be aware what are the pros and cons of the technologies, okay? We need to have some technical skills to work with that. So that's on this level. Next we have the data extraction and analysis. Data extraction means that we take this data from the source. And as I said, for streaming data we have different technologies like Kafka for streaming management. For structured data access in the batch form, we just need some SQL queries, whatever. Yes, and next, obviously, we need to analyze the data. Look at this data, maybe to identify outliers, or clean the data, check for validate the data, for example, for schema or for some other aspects of its data. We are going to have a separate lecture on this. The next stage is data preparation. Typical for modeling, for model training. We need to prepare the data, we need to reshape the data, clean the data, perform feature engineering. We are talking about this in other courses, yes. And next we have model training, which is quite easy, by the way, and model evaluation and validation. And at the end of the day, we have the trained model. Yeah? So that looks like that. It's a bit more complex. Or that may be even more complex. So we have this raw data. We need to separate data extraction stage because of the forms and the volume of the data. Yes. And then we have a separate data analysis stage, separate data preparation stage, model training, model evaluation, and model validation stages. Next, we have a trained model, which we need to save, for example, for future use in the model registry. And that's important specifically if you have, for example, the company who has more than 1,000 models in production, for example, for each customer segment or for each product group, or sometimes for each product itself, stock keeping unit. There are some companies who train the demand forecasting models to predict demand for specific products. So you cope with thousands of models in the production. So for each such a model, you need to retrain the model, yes? So you have a lot of different models. So that's why we need model registry for that. And then when we deploy this into the production service, look, that's a bit slight difference between deploying the model and serving the model. Deploying is a stage where you, as a machine learning engineer, put this model onto the endpoint. The endpoint may be a website, web service, or API, or mobile app, or an edge device if you work for manufacturing. So this is deployment. At the end of that stage, your model is there. But then there is a serving of the model. So you need to take care about the quality of the interaction between the model and the customer. You may have thousands of the requests per minute. So you need to make this system stable, secure, and at the accepted level of latency. Yes, so you have a lot of many different processes running here. So that's the prediction service. And after some time, you need to monitor the performance of the model. You need to track, for example, on a weekly basis, whether this, for example, demand forecasting model decays or not. So if you have 1,000 models in the production, forget about the manual monitoring. You need to have an automated systems which do the job for you. So as you can see, that's a bit more complicated system. In case such a model system performance monitoring system identifies that your model decayed, you need to generate a signal for prediction. So want something real. This is something which you may find in the DevOps platform also. As you can see, in this case, we have plenty of different stages. That's quite complex. Machine learning pipeline for marketing, omnichannel marketing optimization in big pharma systems. As you can see, you have plenty of different artifacts in blue and components. We do some jobs, as you can see in most cases, cleaning, sometimes grouping, yes, merging, and components are here in yellow. So that may be obviously written down as a sequence of Python scripts in one pipeline running on our server, but on the other hand, in the real-life deployment scenarios, each of those yellow components may be a separate Docker container running somewhere in the cloud. So for that management of such a pipeline, you need firstly to manage the infrastructure solutions like Kubernetes, and for managing such a pipeline, other solutions like Kubeflow, which I already mentioned in my previous lecture. So that brings us to the next concept. In our machine learning pipeline consists of artifacts and components. So we need to have this definition at hand. Artifacts are, if you compare it to the production line, artifacts are the things which are in the production, yes, like raw data or sometimes models. Components are scripts which perform some actions on the artifacts. So components do things. If you remember, in project management, we have the concept of so-called work breakdown structure. So if you are going to deliver something, we need to specify the actions required for this delivery. So the actions are represented here in the pipeline as components. Okay. For example, model training. Components do things. Artifacts are those things. Yes, remember product breakdown structure? When we start the project, we need to firstly contemplate what we are going to deliver. If it's a bicycle has some wheels, etc., etc. Yeah? So here in our concept, which is quite universal, components are, for example, trained models or data. That's often visualized in a machine learning pipeline. So this is the example pipeline from Dataiku platform. As you can see, artifacts here are in blue rectangles, components are in yellow cycles. Yes, so we have different data sets. This others data sets go through cleaning and generates others prepared data set, etc. Or that may be visualized that way. This is the same example, but in the Kedro pipeline. This visualization is generated automatically by Kedro by looking at the Python script itself. So that's also a visualization, yes? Or in Kubeflow pipeline. So this is another example of how it can be visualized in the case where we run those components as Docker containers in the cloud, in the set of service. Okay, next very important fact. The whole process is supported by repositories and CI/CD systems, continuous integration and continuous deployment system. And now let's have a look at this supporting infrastructure, supporting systems. And we start with data prep. One of the most important structures here are so-called feature stores. So these are, you can compare it to the database where you store pre-computed features, which may be later on reused by different projects. So it's often used in companies where you have, let's say, dozens of different machine learning projects run in parallel. And imagine that this is, for example, a large website, and it may have many different projects like customer segmentation, this is one project, demand forecasting, this is the second project, yes. Customer behavior prediction, that's another project, yes. And obviously, you may initiate and run each of those projects from scratch. But the problem is that for each of those projects, you will have probably the same data as input. Features like the customer's age, or customer gender, or the number of transactions made by this customer per week. So obviously, you may compute those features from scratch within each of those projects, but it is not optimal. First, and this is probably the most important issue, it's not a technological issue, it's an issue of definition, okay? Because it takes some time to define some features in the process, yes, in the project. So you have a team of persons who work together to define how will we understand this feature. And they get some consensus, and then they implement this feature using different SQL queries. But what's in the case when you have two different teams working on the project and they copy with the same feature and they do not communicate, which is common in large organizations, okay? They may define the same feature in two different ways. And then if you would like to compare those values later on in a business intelligence system, for example, you will get the error. Yes, you will have some inconsistency. So that's why people thought, okay, we may have some features commonly used in our project, so let's define them, let's turn them in one place, and let's make them reusable across many different processes. Moreover, this is another aspect, make them being computed automatically on a daily basis. For example, the frequency is the matter of the needs, so that also make some computational gains. You do not need to recompute them. Moreover, you can track in feature stores those features in time. So for example, each day it's going to be recomputed and you have the whole history of the value of a given feature, for example, for a given entity like the customer. So that's the idea behind feature stores. There are some open source solutions, there are some cloud-based solutions from the main vendors. They are quite expensive, so beware before you turn them on. For example, on the free account, read carefully the pricing, or you can play with that using some open source solution. But that's the general idea of the first structure supporting our machine learning pipeline, feature store. Okay. So now let's continue with model training and model evaluation and validation stage. In that case, we have a family of tools used for experiment tracking. And this is during the experimentation stage, but may also be used later on the production stage. So in that stage, we track the impact of different hyperparameter changes tuning on our model quality. Yes, feature engineering, different algorithms, data enrichment, and all that stuff. Very important family of tools and methods. For trained models, we have this model registry. As I already mentioned, this is a single place where you store different versions of your models, and this storage is probably a bit richer than you expect, because the general idea here is to make this model recoverable after some years from now by you or by some other people. So in such a model, you need to have we need to store the information about obviously the date, who trained, etc., metadata like this one. But you need to have also the data set on which the model was trained and the very specific versions of the libraries used for training. Yes, because we know that models and libraries used for model training evolve. So for such a model, we have all the information, metadata about the training and all the requirements for the libraries and datasets to reconstruct this model training later on, despite it was many years ago. So this is the idea behind model registries. Next, when the model is trained, we have CI/CD, continuous integration, continuous deployment pipelines supported by tools like GitHub Actions or some other dedicated technologies used by different companies. After the model is trained, we need to monitor this model quality, but we need to also monitor the infrastructure itself for latencies, for security, etc., etc. So that's another topic we need to take care about in real life infrastructure monitoring. And since this infrastructure is very specific for machine learning, especially now in case of generative AI, if you would like to host such a model by yourself, you need to invest into graphic cards and servers equipped with very powerful graphic cards. So that infrastructure is also not that easy to manage. Okay, so at the end of the day, the result is that we have hundreds of different libraries only for MLOps. As you can see, we have data collection libraries, data processing libraries, data labeling, machine learning model training and evaluation, machine learning model deployment and monitoring. I like this picture from this sequence from Jesus Rodriguez. I strongly recommend you this person because he writes a really great posts on machine learning and AI in general. Because here, as you can see, you have in colors vendors covering different numbers of stages. As you can see, there are some systems which cover 2 stages, but there are also which cover 3, 4, or even 5. So that makes them quite universal. So as you can see, the picture is quite complicated. So at the end of the day, we end up with the whole bunch of method of tools. So as an AI architect, and what should I know? You might ask yourself, okay, what I should be aware of? My recommendations are the following. Firstly, when you work on a given piece of your project, always be aware of your place in the landscape. What are you working on at the moment? Where are you on this landscape? Yes, whether you're on the data collection, data processing, data labeling, or maybe model deployment or model monitoring. So be aware of your activities. Where are you on the place from the high-level perspective in this landscape? Next, if you initiate the project, for example in your lab, start with the absolute minimum, the simplest dataset possible, the simplest tools, the minimal number of steps. Why? Because if you create such a proof of technology, even not the proof of concept, and later then you develop this, you are always in control. You can see the potential source of the mistake. If you run a huge monster at the very beginning, there is a risk that you won't be able to understand how it works and you won't be able to find the mistake. And, which may be worse, it will compile, it will run incorrectly and you won't be aware of this mistake. And that's the disaster in many cases. Okay, so start with something absolute minimum and then slowly add extra components, okay, to this. So that's why I suggest you to start with something in few lines of code. Next, add extra complication in case they add a real value. If you do not need data lake, do not use data lake, although it's very fashionable nowadays, yes? Obviously, you need to make your pipeline scalable, automate for good, etc., but in case it really needs that. So, do not complicate easy things. If easy solution is fine, go for that. And then, when you need this to be developed, you have a precise need, then you will see whether it's a question of scaling, or maybe you need to add some better model because your model does not meet the business requirements, whatever. Okay, so let's dive in now. Let's dive into model development stage. Let's talk about this. For model training, we have 20 years old but very good methodology of running such a data science project. It's called CRISP-DM. I know that it's old, but it works. I strongly recommend you to have a look at this. It's open, so you can Google this and look at this. In generally, you have the following stages. You have business understanding and data understanding stage. Yes, so you have data scientists working together with businesses, okay, to understand the problem. Then you have the data preparation stage, data modeling stage. Next, evaluation of the model. Data scientist comes back to the business and explains the model pros and cons, limitations, etc. And then they make the decision whether to continue the project, to repeat the loop, or to deploy this to production or kill the project. Yes. As you can see, you have many different stages. For each of those stages in the CRISP-DM, you have the specific outcomes of each stage, like, for example, collect initial data, describe data, explore data. These are the actions needed. And so these are the components in our terminology, and products like initial data collection report, data description report, etc., etc. So this is very, very handy, just not to forget what you are going to deliver on a given stage. There are some more agile and modern versions of that, like here. It's taken from Google. And what do we have here? We have business analysis, we have analysis phase, yeah? So this is the phase stage we work. Next, we need to answer, is developing model feasible? So that's a kind of the proof of concept, yeah? So we select the algorithm, we check whether it works for us. And then, if you are lucky with that, we have the development stage, where we have data pipeline, feature engineering, model building, model evaluation, presentation of results. And finally, the deployment stage with the deployment plan, model operationalization, and model monitoring. Key roles here: business user is here, data scientist is here, machine learning engineer is here, and not visible, extremely important person, data engineer, who is responsible for providing the data to data scientists across all those stages, as you can see, blue, red, and yellow. Okay, so the first stage, business analysis, data exploration analysis stage, is developing model feasible, data pipeline, feature engineering, model building, model validation, and deployment. In our course, we are going to focus on this stage, deployment, with some aspects of model monitoring and data validation. Okay, but this is our course about the deployment phase. Okay, so in general, there are 3 stages in a typical model development phase: problem definition, data preparation, and modeling. Let's start with problem definition. In the problem definition, so we are touching this first stage now, this data science stage. We need to answer the following questions. What is our primary goal in this analysis? Okay, why do we need a model, machine learning model? Yes. How will we measure our success? What are the resources, data time people needed? And why do I present it to you now? Sometimes it may happen that you won't play only a machine learning engineer or general engineer role. Sometimes you may get involved with business into the considerations of the, for example, future of machine learning model development in the company. So these points are maybe very handy for you in the future because they are good points for the agenda of dedicated meetings with the business. Okay, so you may ask during such a meeting, let's say 2 hours long, the following questions during the problem definition stage. And the typical stages, yes, are here in this problem definition stage. Typical phases are: identify a business problem, not ML problem, brainstorm AI solutions, assess the feasibility and value of potential solutions, and determine milestones to deliver and budget for resources. So these are the steps you may proceed with during this stage. Next, you have some second stage outcomes. Okay, what are the outcomes of this stage, problem definition stage? Business metrics like revenue, etc. Machine learning metrics like accuracy, precision, recall, etc. Software metrics like latency, throughput, given computing resources. Resources needed: data, personal help from other teams. Yes, so these are the outcome of that stage. So now let's come to the next stage, data prep stage. We already mentioned we have some data source. Next, we have the data ingestion, data validation, and data transformation stages. And for data ingestion stage, you have data extraction stage, data analysis, and data cleansing. For data validation, you have data validation stage to track whether the incoming data during the training and during the inference comply with the rules you have with, for example, the data on which the model was trained, yes? And for data transformation, you have data analysis, data enrichment, and data transformation stage and feature engineering. Why do I show it to you? Just to show you how complex the real project may be, what are the potential components you are going to deliver, and what are the types of the technology. For example, libraries, whether they are open or commercial, you might need to deploy your real model in the production. So as you can see, I always play around this simple Python script we started with at the very beginning. And data splitting here. Okay, so bam, that was a data prep stage. So for data prep stage, now let's go to modeling stage. So we have some data prepared. Then we have the training stage, evaluation stage, validation stage, and training at scale, which may be something new for you. And in the training stage, we have choosing the algorithm, building the model, and model training. In evaluation stage, we have a model evaluation and then optimization. In validation stage, this is a very interesting stage because we firstly test the model on the data not seen during the training, but in most cases we also provide this model to our business users just for the first validation, whether the results are sensible or not. Yes. So in that stage we also have a model analysis, model validation, and training at scale. Anything we have a data prep, infrastructure prep, and training at scale. And in some cases, it's a separate project because, for example, in the computer vision case, for example, in medical sector, healthcare sector, you may perform these steps on some very small subset of data like images, yes? But training at scale is extremely computing demanding and costs a lot of money, so you cannot run it all the time. So it's run as a separate project in case all those steps worked well on the small sample, yes, because you have to pay a lot of money for training at scale. So that was our modeling stage. So now let's dive into model deployment and monitoring stage. So let's have a look. We have the very, very high level perspective, data source. Next, we push this data for data prep and modeling stages. And this pipeline, as I said, is code or a set of codes or set of containers. So let's treat them as a source code and put it into the source repo. And then, as I already mentioned previously, this is still the code, so we need to push it somehow from the experimentation stage, from our lab, where data scientists, together with machine learning engineers, developed a finally working and accepted code for all the whole pipeline. We need to push it to production. And this is the complete view. This is very important screen for us, for our course, because it shows you the high-level overview of what's gonna happen in the reality. As you can see how to read this graph, at the very top you have model, experimentation, environment, processes, stage. Under the red line you have production stage, yes? So here in the lab, our data scientists with machine learning engineers work on this pipeline. Then we have CI/CD, continuous integration, continuous deployment stage, when we build and test, package, and deploy this pipeline to the production. We have the same pipeline in production here. It takes some data, for example, for external data sets or feature stores, trains the model, puts the model into the model repository, and then you have the model serving stage. So this part is used for provisioning the model to the final customer, whether it's an internal customer like business user or your B2C sector and the customer just as a customer. Okay, so during the stage, your customer asks the question and your system answer the question. Okay, next we need to monitor the model, trigger the retraining signal, and in case the model lost its accepted quality, and then we simply, in case it needs retraining, push the new data after a month, for example, from previous training through this process. Okay, so it looks like that. So That completes the first question. Obviously, my recordings are exemplified with different practice sessions. So, as first at-home exercise, personal, I suggest you to set up a Google Cloud account if you didn't do it yet. Ask, for example, for the student license, you'll get some extra credits. Create a new project there, for example, ASI or whatever. Launch the simplest virtual machine on Ubuntu at Compute Engine virtual machine instances. Note, pay special attention to the region selection. They differ especially in available services. My recommendation is Europe West 4. Install command line interface client for GCP services on your computer and create a command that allows you to start and stop this machine from CLI. So that's the first intro to the word of running your models in the cloud. And the second exercise, collect data from this hyperlink. In my PowerPoints, these are hyperlinked, yes, and store it in your data bucket. Read the data from the bucket to a BigQuery table in the dedicated BigQuery dataset. Create and run a SQL query to store a sample of this table in the dedicated table and read this table into pandas data frame. So you have all these steps precisely described in the PDF file provided. So I guess if you just simply follow the commands, instructions there, you can do it. But in case you can't, I will do my best to prepare also some extra recordings for you with how-to section. And then obviously if you want, you can study machine learning science forecasting modeling where this data source is used, for example, on this website. Okay, so that's all for today. And I hope that this lecture will help you to better understand the whole concept of machine learning model lifecycle and will be a good introduction to our next modules. Yep, this is this. So thank you very much and enjoy. Thank you very much. Bye.